What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light-years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation, Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance, but even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system, Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light-years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff, but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago, But recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted two supermassive black holes, feasting on the cosmic material of two merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch two merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that two gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other. And eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
More than 1 million Earths can fit in our Sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the Sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the Sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. the chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation, and once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the Moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our Sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us. There's only one star in our solar system, the Sun. And all the planets orbit this star. But there are also systems where a planet orbits 2 suns. For example, Kepler 16b. It's an inhospitable and cold place, made of half rock, half gas. But the coolest thing there is that if you visited this planet, you'd see 2 sunsets and have 2 shadows. But astronomers seem to have found something rarer and more bizarre. There might be a planet that orbits 3 stars at once. The GW Orionis star system is around 1,300 light-years away from our planet. It's composed of 3 orange rings. They're made of dust and nested inside one another. In the center of this system, you can see 3 stars. 2 of these stars are binary. It means they orbit each other. The 3rd star revolves around them. Scientists have found out that the 3 rings are misaligned. The innermost ring swings widely in its orbit, and the outermost ring has a tilt of 38 degrees. So, astronomers came up with 2 theories. The first theory says the break in these rings occurred because 3 suns created torque at the center of the entire system. Torque is a gravitational force that always acts toward the center. But sometime later, this theory was written off. There wasn't enough turbulence in these rings for this theory to work. The second theory claimed that this phenomenon could be happening because a planet formed inside one of these rings. A young planet could affect the gravitational balance of the 3-ring system and be the reason they were spread so far apart. There's a specific gap in the dust cloud. Based on its size, the planet we're talking about must be a large gas giant the size of our Jupiter. All space objects have been formed thanks to gravity pulling matter together. If there's even the slightest rotation at the beginning, the spin rate increases with time, especially when an object starts collapsing. That's why all space objects rotate, including dust particles and even black holes. Black holes lose their mass because of a thing called Hawking radiation. Their event horizons are becoming smaller, but this process is very, very slow. A black hole's event horizon is a point of no return. It's like a boundary that surrounds a black hole, and nothing, including light and radiation, can escape once it crosses this boundary. The average black hole would need billions of times the age of our universe to disappear completely. Our home Milky Way galaxy might also contain a supermassive black hole, but we're in no danger. One of the closest large black holes, V4647 Sagittarii, is most likely 20,000 light-years away. It's safe to observe the effects black holes create from a distance. Problems start when you get too close because of their mind-boggling gravitational force. Galaxies can consume one another, which is one of the ways how they evolve over time. Our closest neighbor is called Andromeda, and it's currently munching on one of its satellite galaxies. In the past, Andromeda ate at least 2 others. Plenty of star clusters are scattered all over this galaxy. Andromeda must have stolen these stars from other galaxies. Scientists have finally managed to identify those stars. They have tracked them back to galaxy mergers that happened billions of years ago. 10 billion years ago, our home galaxy also went through a collision. That's why now its halo isn't like the ones other spiral galaxies have. Scientists first thought it was several small collisions, but then they realized that most of these space objects in the Milky Way came from a single source. It was another galaxy, Enceladus, that the Milky Way collided with. The Milky Way and Andromeda galaxy might collide, but it's unlikely to happen in the next 4.5 billion years. Neutrinos are electrically neutral particles that are so powerful that they can go through miles and miles of lead, and nothing will stop them. Some of them are passing through your body as you're watching this. Neutrinos get formed both in the nuclear reactions inside alive stars and in the supernova explosions when stars go out. These particles are nearly massless. They need less than 3 seconds to get to the surface of the sun, and then they can reach our planet in only 8 minutes. There's a planet, TOI 1231b, around 90 light-years away from Earth. It's similar to our Neptune. It's a gas giant, but the most interesting thing is that this planet is likely to be rich in atmosphere. The planet is over 3.5 times as large as Earth and a bit warmer than we're used to, 134 degrees Fahrenheit. It orbits a red dwarf star, way smaller than our sun. But this star is also much older. 1 year on the planet is only 24 Earth days long. Even though the planet is close to its parent star, it remains relatively cold. That's because its star is on the cooler side too. Astronomers think they've seen clouds in the atmosphere of this mysterious planet, and maybe they're even made of water. This star and planet system is moving away from Earth pretty fast. That's why scientists easily detected hydrogen atoms that were escaping from the planet's atmosphere. Yep, that means the planet may even have a tail. A hypothetical white hole is a bizarre space object that is the opposite of a black hole. It's intensely bright and was first mentioned by Einstein in his theory of gravity. Most often, scientists talk about white holes in the context of wormholes. There's a theory that a black hole is like some sort of entry point to a tunnel that takes you through space and time. In this case, a white hole might be an exit located somewhere else in the universe. On the other hand, white holes don't necessarily need to be exits from wormholes. They could also be a slow-motion replay of how original black holes were formed. So, the formation of a black hole starts with an old massive star. After it collapses under its own weight, it usually turns into a black hole. But sometimes, quantum processes don't turn a star into a black hole. Instead, they make a white hole that starts spewing out the matter of the original star again. But so far, this is just a theory. Some planets, like Mars and Venus, have pretty intense weather with powerful storms. And now, an equally strong space hurricane might have come to Earth. It was a swirling mass of air about 620 miles wide. Satellites spotted the hurricane hundreds of miles above the North Pole, somewhere in the Earth's upper atmosphere. The hurricane was raining not water, but electrons. It lasted almost 8 hours before it finally broke down. It was spinning in a counterclockwise direction. It's possible there are oceans hidden under the surface of the moons surrounding Uranus. Scientists have also been investigating the oceans on Jupiter's moon Europa and Saturn's moon Enceladus. These oceans are hidden below the moon's icy crusts. Uranus has 27 moons. 5 of them are especially big. Those are Umbriel, Titania, Oberon, Miranda, and Ariel. Back in the 1980s, when people sent Voyager 2 to get us some images of these 5 moons, scientists found out that they had lots of craters and were made up of ice and rock. Pictures astronomers got then also showed signs of liquid water. It was erupting from the moon's depths and freezing on the surface. One of the most plausible explanations was the oceans under the surface. As a moon moves around a planet, the magnetic field of that planet tugs at it. That is how the moon stays in its orbit. This tug generates an electrical current that transforms into a magnetic field. Such a magnetic field is called induced. and subsurface oceans might be the reason why this induced field can be produced. Saturn is well known for its famous rings, but Neptune, Uranus, and Jupiter also have rings. At the same time, Saturn has something really special we've never seen on any other planet. It's this huge hexagon storm moving around the planet's north pole. Each of its sides is almost 7,500 miles long. That's an area so great, we could place almost 4 Earths inside. According to thermal images, this hexagonal cloud pattern goes down into Saturn's atmosphere for around 60 miles. The planet is hiding behind thick clouds, and sunlight can't get through them. That's why astronomers can't see what exactly is going on there. But there are theories. Saturn is a gas giant. When gas deep inside the planet gets heated, it strays further out. Huge amounts of energy are released along with that gas, which makes it rise, expand, and lose density. The same processes cause hurricanes and tornadoes on our planet. On Saturn, whirling gases come out of a high-pressure zone located within Saturn's outer layers, and these gases trigger a powerful storm of such an unusual shape. The fire and smoke fly upward, and the rocket launches. The Delta IV Heavy is one of the most powerful rockets people have ever made. 3 massive engines burn tons of fuel, helping the spacecraft gain altitude. The 2 side boosters undock, leaving the common booster core for further ascent. When in orbit, the rocket releases its payload. This is the Parker Solar Probe, the first spacecraft to touch the Sun, and we'll follow its journey step by step. The probe was launched on August 12, 2018, and began its journey toward our star. The Sun is 93 million miles away from Earth. That's 390 times the Earth-Moon distance and 36,000 times the width of the United States from coast to coast. The particles of light that the Sun emits need 8 minutes to travel this distance. For our conventional rockets, that journey would take more than 200 days. But the Parker Solar Probe covered it faster, using gravitational maneuvers. On its way from the Earth to the Sun, the probe circled around our neighbor, Venus. All it had to do was enter the planet's gravitational field and let it attract itself. At this point, our space probe got an extra boost, and it didn't need to waste any fuel. After making one orbit, the space probe's engines changed the trajectory, and the probe left the orbit of Venus. It got enough acceleration to travel to the Sun. And on November 5, 2018, the Parker Solar Probe made its first approach to the Sun. Before touching its surface, the spacecraft had to enter the star's orbit first. To achieve this, it did even more gravitational maneuvers. Only after that did it start circling the Sun, the heaviest object in the solar system with the most powerful gravity. So, it'll give the probe an incredible amount of acceleration with each flyby. The Parker Solar Probe was constantly moving between 2 points. Those were the perihelion and aphelion. Look, here's the Sun, and here's the probe's orbit in the shape of an ellipse. The closest point to the Sun is the perihelion. The Sun was pulling the probe there at an incredible speed. At this point, the probe began to move away from the star. It still had a lot of speed and energy, but it was struggling against the gravitational force of the star, so it gradually slowed down. The point where the probe lost all its acceleration is called aphelion. The star's gravitational force won, and the probe began to move back toward the Sun, picking up speed again. The probe made several circles following a stable orbit, but then its orbit intersected with that of Venus again. Another gravitational maneuver, and after that, the Parker Solar Probe's trajectory shifted slightly, and it gained more speed. The perihelion point of its orbit was now closer to the Sun. The probe made several more circles following this new orbit. Then again, it neared Venus. Another approach to the Sun. Each encounter with Venus corrected the probe's trajectory and gradually reduced its distance from our star. In April 2021, the Parker Solar Probe finally came so close to the Sun that it touched its corona. Although the actual distance between the probe and the Sun was 5.3 million miles, that still counted as a touch. Let's look at the structure of our star by cutting it in half. This is the core of the Sun. It's about a quarter of its width. The core is 150 times as dense as water. Because of the intense pressure and high temperature, nuclear reactions occur there. Hydrogen gets converted into helium, giving off an incredible amount of heat and radiation. The next layer is the radiation zone. This is where the heat is transferred from the core to the next layers. But the photons here don't move in an outward direction. They can be directed anywhere and re-radiated many times. Scientists believe that the average time it takes a photon of light to travel from the core to the next layer of the sun is about 10,000 to 170,000 years. Then there's the convection zone. This is what's considered to be the surface of the sun. But it's not a solid surface. It's an ocean of hot plasma. It looks like a bee honeycomb. That's because the heated plasma rises from the lower layers, creating something like mini geysers. And while it's still hot in the middle of those geysers, their edges cool down, creating an amazing pattern on the sun's surface. The next layers are the sun's atmosphere. First, the photosphere. This is the layer that gives off light. And that's exactly what you see when you look at the sun. But careful, don't do that. You need special equipment to look at our star. The photosphere is up to 250 miles thick. This is about the height at which the International Space Station moves above Earth. Then, the chromosphere, or the sphere of color. This layer of the sun's atmosphere gives the star its reddish hue. Solar prominences appear here. Those are powerful emissions of matter leaving the surface of the sun. Their speed can reach 430 miles per second. At some point, they get caught by the star's magnetic field and pulled back. And then there's the corona, a gaseous envelope of the sun. The most powerful ejections take place there. You can see the corona during eclipses, when the moon covers the solar disk. Then you can notice some kind of glow around the star. This is the corona. It extends for millions of miles around the sun. And the Parker Solar Probe touched precisely that area. That's where solar material and radiation are still tied to the star's gravity and don't fly off into space. And all that is beyond that area is the solar wind. It's the material and radiation that managed to escape the sun's gravity and set off into space. The Parker Solar Probe surprised astronomers by providing more information about this boundary. It turns out it's not a perfect circular wall like we used to think. The boundary is broken and uneven. It looks more like a mountain range. These bumpy regions have such a shape because of the uneven flow of plasma from the surface of the sun. The larger and more powerful the flow, the farther the boundary is from the star's surface. But scientists don't know yet what exactly causes this difference. After making the flyby around the sun, the Parker Solar Probe continued its journey and started to move away from the star again. Researchers are expecting another 4 approaches in 2022. In August 2023, the probe will make a flyby around Venus. It'll gain more speed and approach the sun at a record close distance. The next Venus flyby will happen in 2024. And hopefully, the Parker Solar Probe will be able to withstand the high temperatures and radiation so close to the sun. Luckily, scientists have taken care of that. The probe has a solar shield. It's attached to the side of the probe that will face the star. It's about the size of a house window and about 4.5 inches thick. It's made of a special material that can withstand a temperature of about 2,500 degrees Fahrenheit. That's almost 6 times higher than the temperature of a regular kitchen oven. The body of the probe is made of a white material that reflects sunlight. All the scientific equipment is placed right in the center of the shadow of this shield. If the sun's rays hit the unprotected body of the probe at close range, all the equipment will be out of action in just a few tenths of a second. The Parker Solar Probe is equipped with the Electromagnetic Fields Investigation Instrument. This is a system for measuring electric and magnetic fields, radio waves, temperature, and plasma density. The Wide Field Imager for the Parker Solar Probe, or WISPR, is an optical telescope, the one that took those stunning images of the moving plasma in the sun's corona. These streamers are what you see during solar eclipses. The Solar Wind Electrons, Alphas, and Protons investigation measures protons, electrons, and helium ions. It helps scientists study solar winds. It often harms our technology. Unexpected flares on the surface of the sun can cause severe solar winds. They can burn chips and satellites orbiting Earth. Given that we have the ISS, where people work all the time, we need to know more about solar winds and how to protect ourselves from them. While the Parker Solar Probe continues its research, it's already set several world records. It's the closest to the sun human-made object. It's also the speed record holder. During its final approach to the sun, the probe reached a speed of 101 miles per second. That means it could cover the distance from New York to Los Angeles in just 24 seconds. And a trip around Earth would take about 4 minutes. A journey to the moon in such a spacecraft would only take 40 minutes. In 2025, the Parker Solar Probe will make its closest approach to the Sun, reaching a speed of about 430,000 miles per hour. But even this speed is only 0.064% of the speed of light.
So, what's going on with all the news about the Sun? Some say that the Sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the Sun is likely to get. The Sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the Sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the Sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the Sun gives off. Thankfully, the amount of visible light the Sun gives off doesn't change very much. That would be a serious problem. If the Sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the Sun is. The more sunspots that are visible, the more active the Sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the Sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The Sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the Sun. High-speed electromagnetic plasma gas from the Sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the Sun, but they aren't dark. They're just not as bright as the surface of the Sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the Sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the Sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the Sun associated with sunspots. As the superhot plasma gas on the Sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the Sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the Sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the Sun's surface. The corona of the Sun is much hotter than the surface of the Sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the Sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the Sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the Sun. Cool, huh? Turns out the Sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.
In July, when we're about 94 million miles from the Sun, the world is about 36 degrees Fahrenheit warmer overall than in January, when we're 3 million miles closer. This is because there's more dry land in the northern half of the planet than the southern half, and land tends to heat up more than water. During the northern summer in July, more land is heated up than in January. So the planet gets a little warmer at this time, even though we're further from our source of heat. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. But it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look at the moon upside down through your legs. A day on Venus is longer than a year. It takes the planet 243 Earth days to rotate around itself, and only 225 Earth days to make a full circle around the Sun. Around 5 million years ago, the supermassive black hole at the center of our galaxy launched a star from itself, and it's now traveling through the Milky Way 10 times faster than any other star out there. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface showing that it's getting smaller. After more research, they found out that Mercury hasn't finished cooling down yet. The Earth and the Moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The Moon creates tides in the Earth's oceans. They pull back at the Moon and make it speed up. This in turn moves the satellite to a higher orbit. In prehistoric times, the Moon was way closer to our planet than it is now. Luckily, we aren't going to lose the Moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the Moon away with such a force. Discovered in 2017, Kelt 9b is the hottest planet we know of. Next time you're complaining about the heat on a scorching summer day, just remember that temperatures on this planet can reach 7,800 degrees Fahrenheit. That's because it orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our Sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? Everything on Earth, and everything people have managed to see in space with the help of telescopes and other instruments, is normal matter. It's made up of atoms and molecules, and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It got dubbed dark energy. Cold welding is a phenomenon in space when two pieces of the same metal join together without any trouble and heat. About 700 million years ago, a mysterious event that occurred may have turned Venus into the place it is now. Admittedly, astronomers can't see the surface of the planet directly because it's covered with dense layers of thick clouds. But space missions that have been sent to the hot planet found that Venus is peppered with fire-breathing volcanoes, massive mountains, countless craters, and gigantic lava plains. The temperatures on the planet are so incredibly high that they could melt lead, and the atmospheric pressure is so immense that it would instantly crush any living being reckless enough to set foot on it. If that's not enough, the atmosphere of the planet is filled with noxious clouds of sulfuric acid, which smells worse than rotten eggs. Carbon dioxide, the main component of Venus's atmosphere, along with the infamous sulfuric acid, create a powerful greenhouse effect. As a result, the lower atmosphere and the surface of the planet are some of the hottest places in the whole solar system. Neutron stars are the size of a small city, yet their mass is about 1.4 times that of the Sun. They're formed when massive stars die and their cores collapse in on themselves. The core continues to press in on itself until all the electrons are essentially crushed together, leaving only neutrons. This makes neutron stars one of the densest objects in the universe. In fact, a single teaspoon of neutron star material would weigh 1 billion tons. Of course, getting this sample and delivering it back to Earth might be a difficult task, since the gravity on a neutron star is 2 billion times stronger than the gravity on our planet. Because of the effect the moon has on Earth, our planet is gradually rotating slower and slower, and I mean very gradually, at around 17 milliseconds every 100 years. So, it will take 140 million years before the world can add a single extra hour to its day. But that also means that when the dinosaurs existed, there were only 23 hours in a day. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the lunar cataclysm. This interval lasted several 100 million years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. The newest scientific theory claims that Venus could have had a pleasant, stable climate for billions of years before something went wrong. Astronomers did thorough research and built a model of a virtualized Venus-like world. This model demonstrated that for most of its history, the hot planet had oceans with liquid water, adequate temperatures, and stable tectonic plates. In fact, the planet resembled Earth as it used to be at the beginning of its life. Scientists suppose that this period of Earth-like development could have lasted for more than 3 billion years. Saturn is a planet with winds that travel at more than 1,100 miles per hour at the equator. It's also the planet with the most prominent rings. The atmosphere of Saturn isn't really different from its surface, but the deeper you go, the higher the pressure becomes, and hydrogen becomes liquid. Further to the center of the planet, this liquefied gas turns into metallic hydrogen. Like Jupiter, Saturn might have a rocky core, with hydrogen and helium surrounding it. On the other hand, even if it is made up of rocky material, the core can still be liquid. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique systems of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. The sky might appear pretty peaceful as you look at it from Earth, but the Milky Way is headed for a massive collision with the Andromeda Galaxy. 4 billion years from now, you can set your alarm. These galaxies will meet, and neither will survive. Stars will be scrambled, and constellations will be undone. Eventually, the two giants will merge and form an elliptical galaxy. But according to National Geographic, our Sun and Earth will survive. Any life forms on Earth will be treated to a splendid sight as the galaxies come together.
Venus has exceptionally high temperatures, hot enough to melt lead. It's the hottest planet in our solar system, with a high-pressure environment and super strong winds. The winds there are 50 times faster than the planet's rotation. It's getting stronger over time, and scientists don't know why. But they did find something interesting in the planet's clouds, a potential sign of decaying biological matter. Could there be life then? Not quite, since Venus has a dry, windy atmosphere and doesn't have enough water for life to develop. Rings around other planets are more common than we thought. Saturn's rings are the most famous and spectacular ones. They partially consist of reflective, sparkly water ice, and you can't see anything like that in the rest of our solar system. Jupiter, Uranus, and Neptune have ring systems too, and those most likely consist of dust and rocky particles. And not just planets. Astronomers found out rings were around one asteroid as well. Speaking of rings, why do you think that Earth doesn't have them? Gas giants have rings, while the rocky ones don't. Two theories explain how rings form. They could be the remains from the times when planets were forming, or they could be leftover material of an impact that destroyed an unknown moon, or gravity broke apart this moon of its parent planet. It's not clear why only the gas planets have rings. They formed in the outer area of our solar system, while rocky planets only in its inner circles. May be a good clue. Maybe these inner rocky planets had just better protection from strong impacts that could have formed rings. Also, there are more moons in the outer solar system, and there are more rings there. Another thing may be that bigger planets have a bigger volume, so a ring system can remain stable there. Some theories even say that Earth used to have a ring system. A long time ago, our planet collided with a Mars-sized object, which most likely resulted in a dense ring of particles and debris. But our story was a bit different than the outer planets, and those rings probably combined and formed the Moon. Do we know the shape of the universe? Einstein had a theory of general relativity. It said that the universe could be in one of these three forms: closed like a sphere, open like a saddle, or flat like a piece of paper. Its shape determines whether it's infinite or not, and whether it will expand forever or maybe collapse at some point. The shape of the universe depends on its density and rate of expansion. One of the best ways to determine its shape is to use something called the cosmic microwave background. It's the relic afterglow, something that's left of the Big Bang. Sound waves that were moving through the universe in its early stages produced quite small spatial variations in the temperature of its faint light. The result of these studies showed that the universe probably expands in all directions, which means it's flat. How come our sun is hot while the moon is cold? The sun gives off heat because its core is extremely hot. In there, the pressure is pretty high. The hydrogen turns into helium. That's how the sun creates light and heat. The solar light and heat are enough to light up our days on Earth, as well as support life here, even though the sun is around 93 million miles away from us. The moon is not hot because it doesn't have an atmosphere, so it can't absorb sunlight as our planet does. Its surface gets very hot in the daytime, about 210 degrees Fahrenheit, but since there's no atmosphere, the temperature drops extremely during the night to negative 279 degrees Fahrenheit. The sun is hot, no doubt there, but the space around it is very cold. Heat is the energy objects store inside of it. Temperature is how we measure if something is hot or cold. So when you transfer heat to certain objects, its temperature goes up. Take it away, and the temperature goes down. You can transfer heat in three different ways: convection, conduction, and radiation. Convection works within gases and liquids, and conduction is for solids. The temperature only affects matter. Space doesn't have enough particles. It's nearly a complete vacuum, which means transferring heat is not effective. The only way to do it is through radiation. When the heat coming from the sun falls on an object in the form of radiation, the atoms that make up that object will absorb energy. This energy moves the atoms and makes them produce heat throughout this process. In space, temperatures of the objects stay the same for a long time. Cold objects stay cold, and hot ones stay hot. If you place anything outside of the Earth's atmosphere and expose it to direct sunlight, the sun will heat it to about 250 degrees Fahrenheit. Objects in outer space that surround our planet and don't receive sunlight directly are at 50 degrees Fahrenheit. The temperature is like this because there are molecules that escape our atmosphere, so the sun heats them. We used to think that water was really rare in space, but now we know there's water ice across our entire solar system. For starters, you can usually find water on asteroids and comets. It's also in craters on Mercury and the Moon that are in permanent shadows. On Mars, you'd find ice at its poles, under the surface dust and in frost. It might not be enough to support human colonies up there, but it's still something. Some other bodies in our solar system also contain ice, like the dwarf planet Ceres and one of Saturn's moons. Europa, one of Jupiter's moons, could be one of the most likely candidates we know about that could contain life. It probably has an entire ocean under its frozen and cracked surface. It could have twice as much water as all oceans on our planet together. Titan, the biggest of Saturn's moons, also has a liquid cycle, but it's not water. Its cycle moves materials between the surface and the atmosphere. At first, it sounds like the water cycle we have on Earth. But immense lakes on Titan are filled with ethane and methane. There's a chance they're over a layer of water. Neptune is about 30 times as far from the Sun as we are. Of course, it gets significantly less light and heat than Earth, but it also radiates way more heat than it's generating. There are more things happening in its atmosphere, especially if you compare it to its neighbor, Uranus. Uranus is closer to the Sun, but it still radiates the same amount of heat as Neptune. The winds on Neptune are insanely strong, 1,500 miles per hour. No one still knows why. It could be a gravitational contraction, energy coming from its core, or the Sun. I hope we'll eventually find out. Can you imagine hot ice? It exists just 33 light-years away from us, on one exoplanet. This planet consists of different water elements and they form burning ice. The ice there is solid because of pressure, but the surface temperatures are extreme and go up to 570 degrees Fahrenheit. That's how the water stays super hot and comes off as steam. Picture putting ice in your coffee when you want to heat it up. When you stargaze, it's almost like you're looking into the past. Stars are really far away, and it takes longer for their light to reach our planet. So it's possible some of them have already run out of fuel and aren't alive anymore. The Pillars of Creation are a good example. This is part of a region 7,000 light-years away from us called the Eagle Nebula. These are clouds of gas and dust in the shape of pillars. Scientists first discovered it in 1995, but in reality, a supernova explosion destroyed these pillars that were at least 6,000 years ago. So, the 1995 image shows these pillars from 7,000 years ago. Mars has the biggest volcano in the solar system that we know of so far. It's bigger than the whole state of Hawaii, and 100 times larger than the biggest volcano on Earth. The red planet seems so quiet, but once upon a time, large volcanoes dominated its surface. Volcanoes on the red planet can probably grow so big because gravity there is a lot weaker than down on Earth. Also, the crust on our planet is moving all the time, and the Martian crust probably stays still.
So there you are. You've been driving for hours through the night. You didn't have any chance to sleep, so your mind is hanging by a thread. You stop the car and go out to stretch your limbs. And then you look up into the sky and see a beautiful sunrise. Whoa, wait! There are 3 suns in the sky. You rub your eyes, but nope. There are still 3 bright stars in the sky. No, our home star hasn't been torn into 3 pieces, nor has it been visited by 2 other stars. This is called a sundog. It occurs mostly during severe frosts. Small ice crystals in the sky bend the light. As a result, you may see 3 bright spots in the sky instead of just 1. This phenomenon is officially called a halo. Usually it's just a circle around the sun. You can even see a halo at night too. Just look at a street lamp and you'll see a bright circle around it. Sometimes a halo can take on a fancier shape. If there's a lot of ice in the air, the light is warped even more, just like in a room with a dozen mirrors. Then the halo can take on the shape of a human eye. Because of this phenomenon, a false dawn can occur also. While you're looking at the horizon, the dawn begins and the edge of the sun appears. A little bit more and wait! The sun starts to just dissolve in the sky. After a few moments, it's dark again. And only a minute later, the real sun shows its face. It was the same light curvature effect you saw before with the three suns. Only now, the light is curved vertically, not horizontally, and instead of the real sun, its reflection in ice crystals in the sky appeared. But the sun with three stars on the horizon is actually real. Not on Earth though, but 340 light-years away. There's a star system at the center of which lurks a star almost twice the size of our sun. And there are two small stars orbiting around this giant. From afar, they look like dumbbells. This strange world has a planet too. Sunsets and dawns there really happen with three stars. If you brought your significant other to a park bench to watch a sunset here, your date would go just fine. Whatever that means. Now you're at home, watching YouTube to the sound of a thunderstorm. Suddenly, you hear the sound of a window shattering and all the lights in the house go out. You see a streak of bright blue light from under the door to the next room. You open the door and see a sphere of lightning the size of a basketball. It's hanging still, occasionally zipping tiny lightning bolts to its sides. After a couple of moments, the ball flies away toward the window through which it got here. You've just witnessed a ball lightning. Clever name. Such a phenomenon has been observed in different parts of the world, and each time it scared people to bits. In 1753, an experienced sailor went up on the deck of a ship. He looked out and saw a big blue ball of fire over the water. The sailors wanted to turn around and catch up with this mystical orb, but it was moving too fast, and before they could change course, the ball flew upward at a tremendous speed. Then there was a powerful explosion, the force of 1,000 cannons. The boom toward the top of the ship's mast, and several sailors were thrown back by the shockwave. In the same instant, the orb disappeared, leaving behind only the unusual smell of sulfur. And one recent case occurred in Eastern Europe. During a thunderstorm, a ball of lightning flew into a woman's house. The woman remained motionless, and the blue ball flew right over her head. The lightning then discharged into the electrical wiring inside the wall and disappeared. But despite eyewitness claims, ball lightning still remains an unconfirmed phenomenon, and even if it exists in reality, we can't explain how it appears. Some scientists have even been able to create ball lightning in the lab, but those spheres weren't stable and they weren't anything like what the witnesses described. Moving on. This cloud looks like a dinosaur, and this one looks like a cat, and this one, it looks like these clouds are falling down. That's just a mammatus cloud. Their shape really makes them look like chunks of clouds about to slam on the ground. Well, that's not going to happen, but you better start seeking cover anyway. Such clouds are a sign of a severe thunderstorm coming. It takes a lot of moist air with ice crystals at the top and dry air at the bottom to create such clouds. Then vertical currents of air appear between these layers, and these currents make the clouds take the shape of a human brain. And this giant cloud looks like a dome that's going to cover an entire city. In fact, that's exactly what happens. A huge cloud covers a large area and then rains heavily on it. Sometimes the front of such a cloud takes a bizarre shape, like in these pictures. It looks more like several giant spaghetti clouds, or even giant cloud worms. This phenomenon can often be seen in Australia, and it's called a morning glory. It happens because a strong wind twists parts of the cloud on both sides, and then the huge sheet of air dough splits into thick strips. And sometimes you can see clouds in the sky made of birds. Wow, that cloud moves quickly and changes shape. It becomes more transparent and then denser and darker again. The birds seem to be involved in some kind of dance or performance. But they're not doing it for beauty or for the crowds of spectators gathered below. They're doing it for protection. When birds group themselves into such a cloud, they intimidate birds of prey. An eagle or hawk would have a hard time picking out a single target among the endless numbers of birds. And they move quickly, covering each other. Fish are huddled together in schools in the same way. Such a cloud might just spook a hungry predator. For another unusual phenomenon, we'll have to look at the Earth from a bird's eye view, at night. We head to the Middle East. There's a large desert there and it's completely dark, except for one spot. It's a big circle that glows with a bright orange light. the Darvasa crater. And it's just a giant gas burner. Years ago, geologists found gas there, and they started mining for it. But when they excavated, they came across a void underground. The void collapsed and it formed a crater. It's as wide as half a soccer field and as deep as a 5-story building. Gas began to come out of the cracks in the crater, and since animals were often grazing near this place, the gas could harm them. Then the geologists decided to set these gas streams on fire to exhaust the source. One spark, and the crater was filled with columns of fire 30 feet high. Geologists thought the fire would be over in a day or two. But if you come here now, you'll see this gateway to the underworld is still burning, and it's been going on for almost 50 years. In 2013, a man descended to the bottom of the burning crater for the first time. He collected many different samples there, and scientists were able to find bacteria that aren't found anywhere else on Earth. They're quite comfortable at the bottom of this endless burning fry pan. Another mystical phenomenon can be seen in the desert: a sand waterfall. When the wind brings a lot of sand to the edge of the canyon, it begins to fall down. Now amplify this effect 100 times, and you get a sand waterfall in Saudi Arabia. It really is like Niagara Falls, only there's not a drop of water. The locals say this phenomenon warns of an impending sandstorm. And the last phenomenon can only be seen in winter. You see a frozen river, and there's some strange stones sticking out of the ice. But when you get closer, you can get scared, because it's not a stone, but a crocodile snout. Don't fret though, it can't jump out from under the ice and take a bite out of you, and the animal isn't in trouble as you might think. Crocodiles can't breathe underwater, and they need to constantly rise to the surface to take a breath. But when the water freezes, that becomes impossible. So, crocodiles stick their noses out before severe frosts and leave half their body on the surface. They can breathe safely. Plus, the ice and cold air cools the crocodiles and slows down their metabolism. So, that's how crocs can survive the cold and hungry times. And so, this true story about crocs is not a croc. Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
It was September 2nd, 1859. People all over Europe and North America woke up at night, confused and still tired. They were sure it was already morning. It was so bright outside. But when they looked out of their windows, they discovered it wasn't sunlight. The skies were lit by countless intense auroras, red, green, and purple. They were so brilliant, one could read a book as easily as in the afternoon. Auroras appeared even in the regions where they had never been witnessed before, like Cuba, the Bahamas, Jamaica, and Hawaii. Cool visual effects weren't the only thing that both mesmerized and horrified people. The most high-tech stuff at that time, telegraph wires, shorted out throughout Europe and the US. Sparks were flying from equipment, and many human operators got electric shocks. Papers in telegraph offices burst into flames. All the machines were immediately disconnected from their batteries, and still, they mysteriously kept sending broken messages. Fires, ignited by short circuits, spread over large areas. Colorful lights kept dancing overhead. All this caused panic and total confusion. Earth's inhabitants had never seen or experienced anything like that before. At that time, very few people knew that the sun was to blame for the chaos. One of them was English astronomer Richard Carrington. At about 11 a.m. on September 1st, the man was standing by a telescope in his private observatory. He was watching sunspots on the surface of the sun. Suddenly, two patches of intense white light broke out. They looked as bright as direct sunlight. At that moment, the astronomer didn't know what a terrible commotion these flares would cause. Later, it became clear that the sun had produced an epic geomagnetic storm and unleashed it at our planet's protective layer. Wave after wave of charged particles slammed into Earth's atmosphere. The planet's magnetic field wasn't powerful enough to stop them. It gave way, and the storm hit Earth, causing havoc. The phenomenon got the name of the Carrington event. So far, it's been the worst solar storm ever recorded. Good thing it happened when people didn't have advanced technologies and weren't that vulnerable to the sun's geomagnetic fury. The 1859 solar storm was 3 times more powerful than the one that happened on March 13, 1989. 3 days before it began, astronomers watched a massive eruption on the sun's surface. Within a couple of minutes, a billion-ton cloud of gas was hurled away from the star. It rushed straight toward our planet at a speed of millions of miles per hour. On Monday the 12th, the huge mass of solar plasma reached Earth's magnetic field. This storm was so fierce, it lit spectacular auroras and created underground electric currents beneath North America. These currents must have found some weaknesses in the power grid of Quebec, Canada. In less than 3 minutes, the entire city lost power. Millions of people found themselves in pitch-black streets, dark buildings, and stuck elevators. They woke up in freezing cold homes, unable to cook breakfast. The following 12-hour blackout closed businesses, airports, and schools. The Montreal Metro was also shut. In the US, hundreds of power grids started to have problems minutes after the storm hit Earth's surface. Luckily, none of these issues led to a blackout. The storm was severe enough to disrupt satellite communication systems and radio signals. Some space satellites tumbled out of control for a few hours. Lots of them had mysterious problems that went away as soon as the storm began to subside. No newspaper mentioned it, but in 2012, Earth had a close shave after narrowly missing an extreme solar storm, the most intense in the past 150 years. On July 23rd, astronomers at Space Weather Prediction Center in Colorado spotted 2 clouds of energetic particles. They erupted from the sun's surface and barreled into space. Just 19 hours later, these clouds zoomed past the spot our planet had just left. If the solar eruption had happened several days earlier, Earth would have ended up in the line of fire. So, what if a solar storm as powerful as the iconic Carrington event happened nowadays? How much more harm would it cause? Would our life get back on track after such a disaster? Before you learn the answers to these questions, let's figure out what a solar storm is. The sun is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can speed up to more than 600 miles per second. The most powerful volcanic eruptions pale in comparison with solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. When people think about danger coming from space, most of them imagine an approaching asteroid, like the one that wiped out the dinosaurs. But apparently, we should be much more worried about our good old sun. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, several days later, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field, and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have a mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. Those take ages to replace, especially if hundreds or even thousands get wrecked. In some places, a failure of one power grid would make others collapse as well, creating a domino-like reaction. Picture living without electricity for a day, a month, a year. No light, no computers, no phones, water supply systems out of order, no food in supermarkets. Plus, without electricity, it would be next to impossible to reboot the already failed power grids. A powerful solar storm would cost people $1 trillion to $2 trillion, and that's just during the first year after it happens. It would take the world another 4 to 10 years to recover. The damage to all kinds of satellites alone would reach $70 billion. Under majestic auroras, people would have to get used to a new, dramatically different lifestyle. No doubt, we'd have some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. Once a bad solar storm happens, people would have some time to prepare, between several hours and a couple of days. And if transformers are taken offline in time, the consequences won't be so dramatic. Now, the following news might sound scary. There are also super flares. In comparison to them, our sun's bursts of radiation are small potatoes. Super flares mostly occur in young and active stars. In 2016, astronomers saw such a phenomenon. A star 1,500 light-years away from Earth produced a flare that was 10 billion times more powerful than any of those that burst from our sun. It doesn't mean we're safe here on Earth. Even our middle-aged sun knows how to produce super flares, but while young stars can have them once a week or even more often, for the sun, it's once in a few thousand years. And still, if people don't figure out how to protect the planet, just one super flare can shred our ozone layer and wipe out life on Earth.
Ah, beautiful! You're walking with your friend and look up at the sky. The sun looks a bit different today, like it has some kind of ring around it, a rainbow type thing. Huh? Hey, look at that! Your friend pulls his head up out of his phone. You shouldn't look directly into the... Stop everything, he says. It's a sun halo. We need to find shelter now, unless you have the world's biggest umbrella on you. A sun's halo is nature's sign that there's a snow or rainstorm on its way. It's caused by clouds that are made of bazillions of small ice crystals, flying around 20,000 feet. Sunlight goes through those crystals, which causes the light to split and refract, like when there's a rainbow. Now, don't look at the sun halo directly. It's going to be tempting because it's not something you see every day. Plus, it's really beautiful. But ultraviolet light can burn the exposed tissue of your retina and cause serious damage. So, not worth it. Grab some sunglasses and you're good to go. This phenomenon lasts about 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. Nature sends early signs of disasters in many ways. J-shaped trees means there's a landslide coming. Since the ground is moving slowly, the trees grow into the super selfiable shape. Try to find a flat area and avoid going near any trees, unless you have superhuman strength. You're on a nice walk on the beach. Sand, sun, not a cloud in the sky. Then, out of nowhere, you see the ocean going back away from the shore. Suddenly, you can even see bits of coral, small fish, and other random small sea animals. That's a good sign to leave. there might be a tsunami on the way. A tsunami is formed when there's an earthquake underwater, and it can hit the coast at 500 miles per hour. It's mostly a Pacific Ocean thing, but why risk it? If there's a channel of choppy water on the beach, stay away. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange gap in the waves, or you might notice random bits of seaweed going in all different directions. If you don't ever find yourself caught in a rip current, try to stay afloat and don't waste your energy swimming against the current. Yell out for help and try to float your way along the beach. Once you break out of the channel, swim diagonally to the shore. If you find yourself in the ocean and see a group of sharks swimming, okay, this scenario doesn't sound good either way. Well, the good news is they're not necessarily coming for you. The bad news? The sharks might be trying to escape from a huge tropical storm or even a hurricane. Sharks can sense these things, so when nature gets angry, they group together and swim deep under the surface to get to safety. You probably shouldn't follow them. Good luck! The golden rule since ancient times: follow the animals. Insects, rats, and snakes leave their homes a couple of days before really big earthquakes. Scientists can't track or really explain how they know it's coming. It seems animals really can sense earthquakes, maybe because they feel those smaller initial shock waves that we don't even notice. What if you see animals running towards you? Well, that could mean you're about to get eaten for breakfast. Or it means there's a wildfire behind them. Amphibians like frogs, toads, and salamanders try to protect themselves by burrowing down into the ground. Others just run. Before you start running alongside them, check to see if you can see smoke. You don't want to sprint flat out for nothing. Well, it's not just animals. We can spot warning signs too. For example, if you notice your hair suddenly starts to stand on end and your jewelry starts to buzz, take shelter right away. Lightning might be about to strike somewhere nearby. If you're outside and can't run into a house, make sure not to stand near any tall structures. Lie flat on the ground. Be near water. Seek shelter under an isolated tree or stand in an open space. And don't stand on top of the Empire State Building. That thing gets zapped hundreds of times a year. Do you like skiing? It's all fun and games until all you can see is white. Avalanches can move up to 80 miles an hour, so watch for some warning signs. Does it feel hollow when you walk in the snow? Are there cracks around your feet? Can you see a huge avalanche coming? Time to go! Sometimes a storm mixes its blue light with the red light from the sun, and you get a pretty impressive green. Enjoy it from a safe distance, preferably indoors. This super tall thundercloud usually means you're about to get smashed by hail, or worse, a tornado. Find cover somewhere, like in an underground parking lot or a basement. It might be a bit embarrassing if you're wrong, though. Okay, we know volcanoes can be dangerous, but the lakes near them? Is anything not a sign of danger? Lakes that are near something boiling hot that never cools, so volcanoes, are like wildly shaken soda cans, just about to burst. The magma that's underground actually pushes carbon dioxide into the bottom of the lake, and that gas stays there, waiting. Then, even something boring like rain can disturb the lake a little too much and bam, or boom! You get the picture. Diving, swimming, snorkeling, the sea can be amazing, but it's pretty unpredictable. When two wave currents run into each other, they can create a cross sea. It looks pretty cool from far away, but it can be really dangerous for swimmers, surfers, or even ships. There's a strong current roaming around under the surface. You're walking on the beach, apparently every good story starts like this, and all of a sudden, ooh, a cave. How cool is this? You should probably go in there, explore a bit, and no. If there's a full moon out, you might not be able to get out of that cave. A full moon affects the tide and makes it lower than usual. That cave might be more accessible, but instead of an exciting adventure, you could end up trapped in there until the next full moon. Bring a big lunch. A wall cloud is one of those things you're both excited and scared to see. Scared because you don't know what it is. Excited because, well, how often do you see something like that? Whatever you feel, tell your legs to start running. During a thunderstorm, these wall clouds sit lower than anything else and can be up to 5 miles long. And if they start spinning, well, Dorothy ended up in Oz. Who knows where you'll end up? It's 2009 in Italy. A man was hanging out in his kitchen. Then he saw some flickering lights. He knew just what to do. He moved his family to a safe place. A couple of seconds later, a massive earthquake hit the whole region. His family survived thanks to his quick reaction. He knew these flickering lights were actually a sign of an upcoming earthquake. People have been seeing these mysterious lights for ages. Some thought it was some kind of sign coming from space. Scientists never used to take them seriously, but after the invention of photography, more and more evidence of these strange lights appeared. Soon, they realized the connection. The lights appear, and pretty soon, the earthquake hits. After a bit of digging around, they actually found some records of these earthquake lights from hundreds of years ago. There were bluish flames coming out of the ground right before an earthquake. Ooh, creepy. Oh, ocean, come on, not you again. Okay, but just one more. If you see the oceans turned all reddish-brown, don't go in the water or anywhere near it. This red tide is caused by toxic algae and is something you can find all over the world. That toxic algae can be there even if the ocean's a normal color. Getting that stuff all over you can cause some health issues. Rinse yourself off in fresh water as fast as you can. You know, they even wrote a holiday song about it. Algae Home for Christmas. No, really.
The Sun isn't technically the center of our solar system. It's in a space called the barycenter. It depends on which planet you're standing in. The barycenter is usually closest to the object with the greater mass. So, since we're on Earth, the true center of the solar system is the Sun, but not the center of it. With respect to Jupiter, the barycenter is actually outside the Sun's surface. Jupiter is 318 times bigger than Earth, so the balance is different. The planets don't really revolve around the Sun, but around their common center of mass. Imagine balancing a pencil on the tip of your finger. You'd have to place it right in the center so that it doesn't tip on each side. Because the pencil has its mass equally distributed, it's easy to assume that everything balances its way like that, especially in outer space. But try balancing a hammer on the tip of your toe. Chances are you'll walk out of here with a broken toe. Its true barycenter is close to the hammerhead rather than the actual center where you'd grip it. Earth and the Sun's barycenter is like that hammer. The center of mass is more or less in the center of the object. Realistically, if the Sun were to rotate around Earth, then our little blue planet would have to be just as big as the Sun, or bigger. We can't disregard the other planets in our solar system, which means they all will have to rotate around us as well. But in the ancient days, bright minds always thought everything revolved around the Earth. They called this the geocentric model, and this made sense to them because it looked like everything above us was spinning around us. The Sun and the Moon played vital roles in human history, and we didn't feel insignificant in the universe until way later on. In ancient Greece and the Middle Ages, the big brains used the geocentric model to study space. It wasn't until the 16th century that model changed. Back in those times, they couldn't even imagine that everything revolved around the Sun, and they didn't have the knowledge to back any of this up. The Earth can't be the center of the solar system because it's not large enough for the job. For the conditions to suit the enormous size, life would have evolved differently. We'd probably be less dependent on oxygen. Some animals, like whales and dolphins, can stay for hours without taking a single breath. They can even sleep underwater. So the humans of the sun-sized Earth would have specialized lungs and wouldn't need to constantly be taking in air. It means that the plant life would be limited, with just a few shrubs here and there. There are trillions of trees around the world, but the main contributor to producing oxygen is the algae in the ocean. With such vast real estate of oceans and seas, the algae sitting on top are pumping out the air we breathe. Oxygen wouldn't be so abundant on this planet, But our breathing mechanisms might rely on carbon dioxide, another common gas found on other planets. If the planet is hot, then water will be scarce. We would only find it on certain parts of the planet, like mountaintops. The ground would be too scorched for anything to survive in properly. We can forget about seasons as well. The sun is currently just large enough to give us what we need. But since the Earth would be so large, and the sun would be another celestial body emanating heat, we'd always feel like we're inside a microwave. The days and nights will be different, and not much precipitation will happen. With so much heat produced in the core, earthquakes and volcanoes would likely erupt all the time. The surface would practically be a scorching plain of red magma floating around. This would be the true red planet. But if we had the same landscape like on Earth, living somewhere near the mountains could save you. The mountains would still be embedded in the core, but it would be better than staying on the ground. Some of the mountain peaks could even be 100 times taller than Mount Everest. The canyons could be so deep that the Mariana Trench would feel just like a little rupture. Animals would also behave and look different. Cold-blooded animals would have to soak up as little sun as possible so they don't burn. Animals would have to rely on migration to find water in distant lands. Birds can fly for hundreds of miles for migration season, so we'd probably see certain sleek-looking birds speeding through the air. But because gravity would be so strong on the colossal-sized Earth, the flying animals would need thinner bones and a thinner core just to take flight. The real survivors would be the microorganisms. They can live in extreme temperatures and pressures and can live without oxygen for a good while. The nights would be dark since there wouldn't be any moon to reflect the sunlight. The moon would most probably be on the opposite side of where the sun is shining, so it would forever be a floating ball in the sky. The Earth's rotational speed is the fastest at the equator, so if all the planets and the sun rotated around us, then our rotation wouldn't be so significant. New weather patterns wouldn't be good for crops. Humans would have evolved differently from what we are like now. We'd probably be shorter and stockier since gravity is so strong. And because of the soaring temperatures, we'd probably live in caves all around the world. The strongest ones would have migrated to the mountains. We'd probably have the same evolutionary path as we do now, but other physical features might be different. Our pigment would likely look different to combat the heat. The desert fox has large ears for hearing out predators and for cooling itself down in the scorching desert heat. It's possible that we would also have bigger ears than what we have now for the latter reason. We'd be a lot stronger than we are, and our bones would be thick and tough to break. Gravity is one of the key components to developing our bone density and muscle mass. This means we would unlikely need tools for hunting. This would have delayed the Bronze Age and modern civilization as we know it. With little vegetation, standing upright wouldn't be so necessary to find predators around us. We wouldn't be the fastest runners either, but we'd be strong enough to fight off a pack of strange-looking wolves. And if the Earth was supersized, then it's possible that multiple species of humans would be roaming the land in isolated areas. Some human species would grow and evolve into the intelligent thinkers of today, but some would remain the same. And some creatures from the past would still be around, unchanged. Sharks would have been around since the dinosaurs era. They wouldn't have to change their form or adapt because of their dominance. Other animals would remain the same because of their isolation. The Galapagos Island hosts some unique animals because they've been alone for so long. Without proper predators constantly lurking around them, they don't fear humans. The new mega-sized Earth would have areas as large as Asia filled with isolated animals that could remain the exact same as when they first appeared. The human species of those regions would also remain the same, since they wouldn't have moved or experimented with anything. Their diet would remain the same, and they would get used to the climate they're in. Technology would also have flourished differently in various parts of the planet. With some areas in complete isolation, they wouldn't have access to new gadgets and inventions. It would be like living on a planet with different eras in the present day. Other areas would be so advanced, they might even be flying themselves outside the planet in search of truth and answers. Our gravity is good enough for us to live properly and develop life, but if we pumped up our size to that of Jupiter, then gravity would crush us. And being the size of the Sun, Earth wouldn't even be a planet, but a brown dwarf, and would constantly be burning until it became a new sun. As of now, Earth is so small in our universe that we're practically like a grain of sand in the desert. On a cosmic level, we're an insignificant contribution to this universe.
You may think the Earth is pretty big, but the Sun makes up almost 99.9% of the mass of the whole solar system. The rest of the mass is made up by the planets and their satellites, asteroids, comets, gas, and dust. It's around 93 million miles away from our planet, but it keeps us warm every day. Its temperature is about 10,000 degrees Fahrenheit, but the space surrounding it is still cold as ice. To understand this, we need to distinguish between heat and temperature. Heat is the energy inside some object. Temperature is something that tells us if that object is hot or cold. When the heat is transferred to that object, it makes its temperature go up. When the object is losing heat, the temperature goes down. Heat can be transferred in 3 different ways. The Sun does it through radiation. That means it's releasing heat in the form of light. Your body radiates heat too, as infrared waves. That's why thermal imaging cameras will detect that you're in the room even at night. The hotter the object, the more heat it will radiate. The temperature only affects matter. Since space is mostly a vacuum, it doesn't have enough particles for heat to transfer in any other way than through radiation. When the heat from the Sun gets to an object, the atoms start absorbing energy, but the heat can't transfer since there's no matter in space. Those rare atoms and molecules in space will absorb the heat. And they'll simply stay that way, while the cold vacuum will stay cold. There's a lot of matter inside Earth's atmosphere, so the energy of the Sun can transfer easily. But if you put an object outside of the Earth's atmosphere in direct sunlight, it would end up heated to 250 degrees Fahrenheit because it's matter made of atoms and molecules. The temperature of the vacuum is negative 454 degrees Fahrenheit. That means, depending on where you are, space can either burn or freeze you. The Sun isn't actually yellow. It emits light over a wide range of wavelengths. We can tell both its temperature and color by the peak in its spectrum. For instance, cooler stars will appear red, and hotter stars will be blue with yellow, orange, and white stars in between. When it comes to the Sun, the spectrum peaks at a wavelength we'd usually call green, but our eye perceives it differently. So, the shade of green in combination with other wavelengths from the spectrum is going to look white to the human eye. We generally see the Sun as yellow because our atmosphere scatters blue light more efficiently than the red one. During sunrise and sunset, there's more red light in the spectrum of the Sun, which gives us amazing sceneries. Sunspots are part of the Sun's visible surface that are on average way cooler than the Sun itself. They overlap with parts that have an increased magnetic field. These parts don't allow the release of heat to the Sun's visible surface. That way, the rest of the Sun's surface is 3 times brighter than those sunspots. That contrast makes them appear almost black. If we could take a sunspot apart from the Sun and place it somewhere in the night sky, it would be different, as bright as the moon when we see it from the Earth. All the planets in our solar system spin in the same direction because they were formed from one protoplanetary cloud, except for Uranus and Venus. They have probably had some strong impact on them that made them spin in the opposite direction. But it's different with galaxies. They don't usually form the same cloud of dust and particles. Also, they're not randomly distributed across space. They come in filaments, dense, slender strands of dark matter and galaxies, with voids in between. Proto-galaxies are linked by gravitational forces in small areas of space. This is probably because of the distribution of dark matter throughout the universe. The matter in the filaments moves in a corkscrew motion and goes towards the densest area. So, there might be a common direction galaxies tend to spin, but it's mostly random. There's a possibility we'll see a lunar elevator one day. Yep, a cable anchored to the surface of the moon. It would stretch 250,000 miles. We wouldn't be able to directly attach it to our planet because both Earth and the moon are moving. But we could keep it terminated high in our planet's orbit. Some researchers believe we could build such an elevator for a few $billion. The moon has resources we could definitely use. A rare form of helium found there could be of use in fusion power stations on our planet. Also, we could take some other rare elements and use them in smartphones and the rest of electronics. So, after around 53 trips up and down, the elevator could pay for itself. The cable would be as thick as a pencil, but its weight would be around 40 tons. It could even be made of materials we already have here on Earth with no need to invent something. There could even be a combination of two elevators. A spacecraft would winch up an elevator from the surface of our planet to a space station. Then it would be flung towards the moon. There would be another elevator to finally lower it down to the surface of the moon. Planets in our solar system have predictable and stable orbits, but gas giant collisions could have happened at an early stage when a planetary system was still forming. In case of a head-on collision, two gas giants would merge. They wouldn't end up losing their mass, the materials in their gaseous envelopes, or the ones in their solid cores. Such a collision at a higher speed would cause the loss of the major part of the envelope gas, and very high speeds, boom, both planets are gone. It's different if it's not a head-on collision. If two cores manage to completely avoid each other, gas giants won't merge, but they'll lose some of the mass. Gas giants might even change their shape due to such collisions. Astronomers found out there's a galaxy extremely far away from us that looks similar to our Milky Way. We now see it as it was when the universe was only 1.4 billion years old, and now it's 13.8 billion years old. It took over 12 billion years for the light to come from this faraway galaxy and reach our planet. This galaxy is peaceful, stable, and surprisingly non-chaotic, unlike all other galaxies that were quite turbulent in their early stages. To leave the Milky Way, we'd have to travel around 25,000 light-years away from the center of the galaxy, or 500 light-years vertically. Our galaxy is a disk of stars that spreads around 100,000 light-years across and is 1,000 light-years thick. The Sun, its central star, is located halfway from the center of the galaxy and close to the middle of the disk in the vertical direction. We'd have to go further than its edge to get away from the halo that surrounds the Milky Way, old stars, diffuse gas, and globular clusters. If you wanted to go even further to see the Milky Way in all its glory, you'd have to travel 48,000 light-years vertically. At this moment, we don't even have a telescope we can send there. There are central stars that eat planets. Our solar system is stable, unlike many other planetary systems. So we don't have to be afraid the Earth or some other planet will change its orbit and go towards the Sun. But at least a quarter of other planetary systems with orbiting stars similar to the Sun have a pretty chaotic past. In some of them, there are planets that used to move around, and their unpredictable migrations have disrupted the paths of some other planets, or even pushed them outside of their orbit. That means some planets probably have fallen into the central star. When that happens, the planet gets dissolved in the outer layer of the star, which means it gets eaten.